We're all horsepower junkies, and a lot of people have learned that an easy way to make a lot of power from a conceptual standpoint is through a turbocharger. But boosting an engine isn't necessarily an easy thing to do, and then boosting an engine correctly and have it make tons of power, again, is not easy. And then to have it all look cool, I mean, that's an accomplishment. And today we found Tom Nelson of Nelson Racing Engines, who manages to do all of those. Tom, why don't you give me a little bit of background on how you got started playing with motors and building turbo systems and the whole deal?
I've always been around it. My dad twin turbocharged his Pantera when I was like 12. We would always go to Laguna Seca and he'd be racing it. So I was always around the industry. And then we just started go-kart racing, and then actually started illegal street racing and making a living off of that. And then I decided I actually had to get legit and not actually break the law. So then I opened up Nelson Racing Engines in '94, and then we've been doing it since '94 and just playing with it every day.
Well, although nobody condones illegal street racing, it's kind of interesting that, I guess it's a performance-proven way to make a living. I mean, if you're not making the money in the races, then you don't progress. So that's where you kind of learn the craft, huh?
Yeah, I mean, you definitely learn fast because, you work all week, and then Fridays was the day, so you would run on Friday, and if you lost, you lost your living, so you had to be good at it,
It's good to see you went legit.
Yeah.
Well, let's talk about some of the stuff you've brought out today. We're standing in front of a big block Chevy that looks more like a piece of jewelry than something that belongs under a hood.
Yeah, that's what I've really been trying to do. I've been trying to develop an entire package where when the customer buys a motor from me, he doesn't have to spend another 100, 200 hours of fabrication. So these packages that I sell, they're complete. They come with the fuel pumps and the intercoolers, and it all mounts in the car, and it's wired, and it's good to go. And I really wanted to do something special, so we make the valve covers from a billet. We're making the collectors from a billet. We're making the turbochargers from a billet. The whole intake manifold we cut from a billet has everything hidden inside. The injectors are hidden, the sensors, the throttle linkage, all the fuel regulation is built into the intake. So it's really something I've just been working on all the time. We've developed this fuel regulation plate, and the real deal here is we run 2 injectors per cylinder. So we run the motor on a small primary injector that has a really nice spray pattern. The car starts, it idles nice, it cruises nice, and then once it gets into boost, the computer automatically will turn on the secondary injector. And we call that octane on demand. So we'll usually feed the second injector out of a race gas fuel cell. So it injects race gas only under demand. Now, the way we've done this is the primary fuel, and that's the secondary fuel. The primary fuel will shoot straight across into this regulator body and then come out in a return there. The secondary shoots straight across, comes out in the return right there. This is the regulator body we've built, and we internally boost reference the fuel pressure, so for every pound of boost, it increases 1.7 pounds of fuel pressure. So we drill the regulator body, and then we drill the regulator plate, O-ring seal it, and drill the plenum so it's all completely encased and you have no lines. So for this entire 16 injector fuel system, you have 2 fuel lines and 2 return lines, and it's completely done, but it'll support up to 3,000 horsepower. So this is a small block example. It has the hat removed off of it, but you can see it's very similar to what we have for the big block, is we have fully CNC radius into the ports. And another thing we've done is we've taken the injector, which is normally shooting straight at the floor of the port, so you get an atomized fuel that it hits the floor of the port and it turns into, it's not atomized anymore. So we've taken the injectors and we're shooting it straight at the back of the valve. So both injectors shoot straight at the back of the valve so they don't hit the floor anymore. So it stays atomized. So we've actually been able to reduce 30% of the fuel used at, like, let's say you're making 1,500 horsepower. I'm using 30% less fuel than I would with a conventional setup. So it has really worked out good, and we've changed the plenum volumes around. The throttle response on this setup is just unreal. It's like nothing you've ever done on a turbo motor. It actually revs like a 16-to-1 NA motor, but it's a turbo motor. So it's really worked out good.
Man, it's beautiful. And the CNC ports and the injectors then mount inside here underneath, right down the middle.
Exactly. If you take a look at how you can see, if you film in there, you can see the dual injectors per cylinder, and it's all hidden, you know.
You mentioned your new turbo design. What's this all about?
Well, for the past 10 years, you know, we've made complete systems, and you know, a normal turbocharger, it only goes one direction. So this is the direction a turbocharger would normally go. So when you have a twin turbo application, you have two turbos that are the same. So you have to make two different headers, two different intercooler pipes. It's never the same. And in one respect, it makes the motors offset because you've got, you know, one side of the motor different lengths than the other side. So we've come out with a clockwise and counterclockwise turbo that makes the installation totally Sano, and we're doing it right now out of billet, soon from a casting. And you can see that when you put them together, you've got clockwise and counterclockwise. Although we mirrored this, so the names backwards here. So, but I mean, it really does a super Sano deal. And perfect example is this has a symmetrical setup on it right now. If you take a look at it, it just the whole setup is very balanced, and it just looks like it should.
Well, the stuff that I'm noticing, again, we've got your intake up on top, we've got your billet valve covers, we have the surgically precision bent lines. Is that bent fab working again?
Mark's the surgeon on that one, so, you know, I'm not going to take credit for that one. Mark is just he's a genius when it comes to bending lines.
And then we have your stainless turbo headers, and we can now see, like you're talking about, how it's almost like the ram's horns are pointing the right direction, and it fits killer. What kind of power does this particular setup make?
This motor makes 1,750 horsepower, but this is a total driver. Idles at 800, and you could literally drive this to Vegas and back, no problem. I mean, we have different combinations that make 2,500, but this is my favorite. It's a 427 small block. I mean, it's just got tons of torque. It makes 1,540 foot-pounds at 3,600 RPM, to give you an idea how much torque it makes.
And this is a traditional small block?
Traditional small block, yep.
Now, what do you do to the bottom end to make a traditional small block live with this kind of power levels and be daily drivable?
I mean, everything, basically. You know, you've got a special dart block, steel caps, you know, Cali's Magnum, Oliver billet rods, custom pistons, custom rings. All the machine work is set up specifically for the motor. We changed the cam tunnel, make it a huge 55 millimeter cam. We bore the lifters out to a Chrysler 904. We do all sorts of stuff that, you know, for the last 15 years figured out, you know, what breaks and what doesn't. And this thing will be as reliable as any motor you can. I mean, we put 400 pulls on the last one, and, you know, normally you'd get 50 on that kind of power level. 400 pulls, tore it down, didn't even change the bearings, put it back together, it's still running, you know. So, I mean, they're super, super reliable.
That's awesome. I love the fact that now we're living in a world of technology that allows this stuff to happen. What do you guys use for engine management?
I use an Electromotive Tech 3R, and, you know, I've just had a super relationship with them, and they've been super helpful with me, so I really like it. But the real benefit to the Electromotive is the ignition setup. They use an inductive ignition that's patented. Nobody else has it, and it's increased bearing life almost 50% just switching to that ignition system.
Really, just because of the more precise timing?
Yeah, it stays lit for a much longer crank duration.
Okay.
Where capacitive is a really high intensity, short duration burst. And not only that, they use a 60-2 pickup, whereas most systems are using every 90 degrees, which is 4 pickups.
Right.
So the resolution is just
much cleaner.
It's much cleaner.
It's almost an analogy of a nitrous car versus a turbo car.
Exact. There you go. You know, the nitrous guys are honing their blocks in the pits, putting pistons in it, and the turbo guys are changing oil. You know, so
nitrous hits real hard and brakes.
Yeah.
And
exactly.
Well, I'm truly impressed. I mean, your stuff is fantastic. I'm going to steer people to your website to learn about the supercar.
Great.
What is the website address?
It's NelsonRacingEngines.com. Then we have NelsonSupercars.com. And then there's also NRETV.com, which is all the videos.
Awesome.